So dear students, today I am going to discuss about the oscillation chapter. It is very important for the CE exam. Oscillations, basically it is related with the wave. So now what is the meaning of oscillation? So you have a lot of ideas about the oscillations. That means vibrations or oscillating body or oscillatory motions. So you have a lot of experience about this. First you see, when we are talking about the oscillations, So meaning of oscillations means, suppose if you consider this is a kind of bob, this is a kind of rigid support, one is bob is here, and due to the force when the bob is vibrating to and fro motion, it is going forward direction as well as backward directions. And if we consider like this, so there is a angle, so it is going forward direction. This is a kind of displacement from the main position, it is considered x displacement, and here left side you can see there minus x displacement. So in this case you can see this is a rigid support. From the rigid support, when a bob or pendulum is vibrating to and fro motion, this is called a kind of oscillation. So meaning of oscillation means vibration per second or number of oscillation per second. For example, you see, suppose a car wheel is rotating. So car wheel is rotating with high speed. So per minute or per hour or per second, what is the rotations? So number of oscillations basically calculated with the help of frequency. So you remember, oscillation basically it is representing to and fro motion. It is going forward direction and backward directions. So in case of oscillation chapter, basically you should know about the periodic motion. So what is the meaning of periodic motion? Periodic motion means basically it is going up, down, up, down. So this is a kind of periodic motion. So within time interval, the wave repeats itself. So then it is called periodic motion. So basically in this chapter you should know about the oscillation. Oscillation basically it is related with the number of vibrations. So in this case you remember, when we are talking about the oscillations, then at the time this is a kind of wave. There is a vibration, this is a kind of wave. This is a kind of wave. So we are getting this is a kind of wave. So if you draw like this is a kind of wave. So wave is the example of oscillation in motion. Now in this case you can see here, this is a kind of wave. So from this main position, here main position, this is main position, here maximum displacement, this is a part of maximum displacement, and this maximum displacement it is called amplitude. So this part is a amplitude, you remember. And from this origin main position, so when the wave is going into forward direction, at the time it is the position where the time is t by 2, and from this position to time is t. So basically you always remember, when the wave or oscillation takes place, wave is moving into forward direction. At that time we are getting maximum amplitude, that means maximum displacement, this is called amplitude. So oscillation is also a kind of wave. So what is the equation of wave? So I think you have idea about the equation of wave. So basically equation of wave means it is given y is equal to a sine omega t. This is the equation of oscillatory motion, or this is the equation of wave. So how it is possible? Y is equal to a sine omega t. This is a kind of equation. So dear students, you always remember, in case of oscillation or in case of vibration, we are getting two types of equation. One is y is equal to a sine omega t, and here if you write the displacement x, it will be a cos omega t. So you remember, y is equal to a sine omega t. This is a kind of oscillation along y direction, and this is the oscillation of the particles along x direction. There are two types of equations we are getting: displacement along x direction as well as displacement along y direction. Now here y is a displacement and a is the amplitude. This is called angular frequency. So this is the formula for wave. So this is the equation of wave. So first you remember equation of simple harmonic motion. You can say also simple, already the definition already you know. So in case of simple harmonic motion, you remember number one, equation of simple harmonic motion. So equation of simple harmonic motion, you always remember y is equal to a sine omega t. Y is equal to a sine omega t is the equation of simple harmonic motion. So these equations we can also express x is equal to a cos omega t. This is the equations of simple harmonic motion. So here you can see a is the amplitude sine omega t cos omega t, y and x is given. So another formula we can also write like this: y is equal to a sine omega t plus phi, and here x is equal to a cos omega t plus phi. So these two equation is the equation of simple harmonic motion without phase and with phase. This is called without phase, without phase, without phase, and here with phase, with phase, with phase. So dear students, you always remember the numericals may be given related to these equations. You always remember here y is a displacement and a is a amplitude, and here omega is a angular frequency. Now from the given relations it is clear that, and here you remember phi is a phase angle. So here you remember phi is a phase angle. So note, you can write phi, that means phase angle, phase angle. We can write phase angle, phi means phase angle, and here a means amplitude, a means amplitude, a means amplitude. So dear students, you always remember the unit of amplitude. What is the meaning of amplitude? Maximum displacement. This is a maximum displacement. Maximum displacement means it is calculated in terms of centimeter, in terms of meter. So that is why the unit of amplitude will be centimeter, either centimeter or meter. And phase angle, here you can see phase angle, this is calculated in terms of angle. Now this is the equations already go. Y is equal to a sine omega t, x is equal to cos omega t, and here y is equal to a sine omega t plus phi. This is a with phase, this is a phase angle, and without phase, and this is a phase angle. So now in this equations I am going to discuss one questions, and these questions are very important for you. So now see question related with this equation. Suppose you have given one question in short I am giving the questions. Suppose you have given, so y is equal to, suppose 5 sine 314t plus pi by 2. So this is the equation is given to you. So from the given equations you just see it is completely related with this. So from the given equation, so how we can calculate the value of amplitude? So find the value. Suppose here given find the value of, find the value of. So find the value of first amplitude. Suppose a number, amplitude, we have to calculate amplitude. Number b, angular amplitude, then angular frequency, and number c, you remember amplitude, angular frequency, then normal frequency, then d number time period, and e number phase angle. So how we can calculate this term amplitude, angular frequency, time period, and phase angle? That means amplitude, that means we have to calculate value of a, angular frequency we have to calculate omega, and here frequency we have to calculate nu, and time period we have to calculate t, and phase angle we have to calculate phi. So these quantities we have to calculate from the given relations. Now in this case you can see this is our formula. So here phase angle is given, so this relation it is completely related with this, so that is why we will use this formula. So now you can see how we can solve the numericals. So solution, and here you can see this is the equation given to you. Y is equal to 5, y is equal to, here given 5 sine 314t plus pi by 2. So you can see here, this is the relation, this is the equation is given to you. From the given equations, we have to calculate the value of amplitude, we have to calculate the value of angular frequency, we have to calculate the value of frequency, time period and phase angle. So first, this is the relation is given to you. Now similar equations, I have given 4 equations. So which one equation will be used here? Third number equation. So you just give equation number 1 and second formula, that means a sine it will be omega t plus phi. This is the general formula or normal equations. So in case of general formula or normal equations, you always remember we have to compare, that means comparing both sides, that means comparing equation 1 and 2, comparing equation 1 and 2. So in short, you remember a is equal to phi. Suppose if it is given centimeter or meter, suppose it is given meter, so you have to write meter. If it is given centimeter, then you have to mention centimeter. Now, so amplitude of the wave or of the oscillations will be a is equal to 5 meter. So number A, amplitude, done. Number A, done. Secondly, angular frequency. Now see, angular frequency, this term and this term we can compare. So here it will be omega t is equal to 314t. So t cancel, omega is equal to 314. This is the value of radian per second. So omega is equal to radian per second. So this value we can write 314 radian per second after comparing both equation 1 and 2. Now the first one done, second one also done. The frequency means, you remember, frequency means omega means you always remember omega twice pi nu. So we need to calculate the frequency. Nu here omega is equal to twice pi. So here omega means 314 and here what is the frequency? And here you can see 2 into 3.14. So it will be 314 and here 100, 2 into 314, it will be 50 hertz. It will be 50 hertz. So answer will be 50 hertz. That means frequency will be 50 hertz. So this one done. And D number, you can see time period. So already you know this is the formula in class 9 already got. So T is equal to 1 by nu. Nu means frequency. So it will be 1 by 50. 1 by 50. T is equal to 1 by nu is equal to 1 by 50. So this is the time period. Time period basically it is calculated in terms of second. Now phase angle, you can see the last number of phase angle. The phase angle here given number E. So phase angle number E. So if you compare this part and this part, that means phi is equal to pi by 2. This is called phase angle. So dear students, you always remember in these chapters always you have to compare the normal equation and equation which is given to you. So after comparing both equation 1 and 2, we are getting all these values. So this is the solution. So in your C exam may be given only you have to given suppose amplitude. So this is the process. In this process you can easily calculate the value of amplitude. Suppose you have this relation is given to you and the question will be given like this. Which of the following option is correct for amplitude, like this. So I am going to discuss one more question related with this. You just see. Now you can see, suppose you have given one question, the displacement y is equal to, it is given suppose 5 sine 3 35 t, it is given. So the angular the amplitude will be option A, it is given 5 meter, option B it is given suppose 10 meter, and option C it is given 15 meter, and option D it is given minus 10 meter. So you can see normal equations already you know. Y is equal to suppose 5 sine 305 t. So what is the normal equations? So how we can solve it? You can see. So in this case you remember here the amplitude will be, so normal equation solution you can see in short, y is equal to 5 sine 35t, it is given equation number 1, and normal equation already you know, y is equal to a sine omega t, equation number 2. So normally no need to do this one, directly amplitude a is equal to 5, so 5 meter. So amplitude will be 5 meter, So you remember, in this way we can easily solve the numericals related with the equation of simple harmonic motion. So next you see, I have given equation of simple harmonic motion. Next you can see velocity of acceleration of simple harmonic motion. So now see, next topic will be velocity of simple harmonic motion. So normally you know the equation y is equal to a sine omega t, it is given omega t. So after differentiation, so velocity will be like this, v is equal to omega under root a square. That means how we can write, you can see, suppose this is y is equal to a sine omega t. So in this case we can write dy by dt. So it will be a cos omega t into omega. So here you are getting a omega cos omega t here. So again differentiation, velocity, this is a velocity. So v is equal to a omega, and here cos omega t means 1 minus sin square omega t. So here sin omega t means y square a, so b is equal to a omega under root, we in short write 1 minus y by a whole square. So it can be written as a omega, it will be under root a square minus y square divided by a. So this is a cancel with each other, so omega is equal omega a square minus y square, and here b. So you can see this is the velocity you are getting. So b means velocity is equal to omega under root a square minus y square. So here omega means angular frequency, b means velocity, a means amplitude, and y means displacement. So this is a kind of formula. So what is the maximum velocity? This is the velocity of simple harmonic motion. So maximum velocity. So maximum velocity. So basically we are getting y is equal to a sine omega t. This is the normal equation given to you. So differentiate it, dy by dt. You can see dy by dt. So we can write a cos omega t into omega. So in this case, dy by dt means we can write velocity a omega cos omega t. So when we are talking about the maximum, it will be a omega. So this is the relation. So you remember here v is equal to omega under root a square minus y square, and here maximum velocity a omega. So here this is a means amplitude and omega is your angular frequency. Next you can see, so we are getting here this formula, that means simple harmonic formula. So you remember B max is equal to A omega. Now see dear students, so we are getting different types of formula in this chapter. You can see number one y is equal to A sin omega t. This is a kind of formula. We can write in terms of component x also, y also. So I have written only one equations. And number two we can write here v is equal to omega under root a square minus y square, number 2. And number 3 we are getting maximum velocity is equal to a omega. And beside number 4 you can see v is equal to nu lambda, also you know b is equal to nu lambda. And number 5 and frequency is equal to 1 by t. And number 6 you can see frequency is equal to n by t, n by 2. So here you see one oscillation, and here for n oscillation, for one oscillation. So this is the formula you remember. And number 7 number formula here given, omega is equal to twice pi nu. That means 8 number formula will be omega is equal to twice pi n by t, and sometime it is also we can use twice pi n by t. This is the formula. Now see, dear students, here I have given this formula. Basically we are going to use in case of oscillation sector. Now see, so this formula I have discussed, this formula I am going to discuss now. Suppose you have given one question to you, so how we can calculate the value here? Suppose one question I am going to discuss. Suppose here you can see this is a angular velocity, here amplitude and displacement, and beam is velocity. Suppose velocity, in short I am giving, suppose velocity of a particle, suppose 3 meter per second, and displacement 4 meters. So velocity of a particle is 3 meter per second and displacement 4 meter per second. On the other hand, the displacement of a particle is 3 meter, and velocity 4 meter per second. So what is the value of amplitude? The value of amplitude, that means find the value of amplitude. Find the value of amplitude. Find the value of amplitude. We have to calculate the value of amplitude. So in this case here you can see there is a two conditions. Normally we have to use this velocity formula, that means number 2 formula. So in this case you remember solution. For the first case it is given, you can see velocity of the particle is given 3 meter per second. That means velocity here given 3 meter per second. And here velocity 3 meter per second, at the same time displacement it is given. Displacement basically it is represented by y is equal to, it is given 4 meters. And second case here given velocity is given 4 meter per second and displacement here given 3 meters. So using this formula, equation number 2, you can see serial number 2, that means V is equal to omega under root a square minus y square. So using this formula we will get the value of B is equal to 3 and omega under root a square minus y, means it will be 4 square. So 9 is omega square and here a square minus 16, equation number 1. Now you can see here using this same formula, B is equal to omega under root a square minus y square. In this case we will get the value of V is 4 and here omega under root a square minus 3 square. So we will get 16 is equal to omega square a square minus 9, equation number 2. So dear students, I think you got the idea. That means if the question is given in this way, then you have to first calculate like this. So now the first equations we are getting 9 is equal to omega square a square minus 16, and here 16 is equal to omega square a square minus 9. Now so we have to calculate the value of amplitude. Amplitude means E. So how we can calculate the value of amplitude? So equation number 1 and equation number 2 is given to you. So just you divide equation number 1 and 2, then you will get the final result. So now this can be written as you can see we have to calculate the value of amplitude. So that is why you can see the further here given equation number 1 and equation number 2. So we can write like this 2. So 1 by 2. So 1 means here given 9 and 2 it is given 16 is equal to, it will be omega square a square minus 16, and here it will be omega square a square minus 9. So in this case you can see this one cancel with each other, so we can write this one. So 9 a square minus 9 and here 16 a square minus 16. So in this case you can see here 9a square 81 is equal to 16a square minus 256 like this. So from the relations we can write here, we can write 256 minus 81 and here 16a square minus 9a square. So this is the simple relations. So from the relations we can write here, it will be 16 minus 9, it will be 7a square, and here we can write 256. You see 256 81, so it will be 6 minus 1, that means it will be 5, and here 15 it will be 7, 175. So a square is equal to 175 by 7 and a is equal to under root like this 175 by 7. So this is the final result. So if you just simplify the relations, then you will get the amplitude. So in this way we can easily calculate the value of amplitude. So this is the idea for calculating the amplitude and which is given in the question. Now you can see this is the process. In this process we can easily calculate the value. Now how we can calculate the value of maximum velocity? Here given maximum velocity, this is the maximum velocity. So using this formula, how we can solve the numericals? So maximum velocity, how we can calculate? Suppose you have given one relation. This is the relations you have given. Y is equal to, here given suppose 50 sine 450 it is given to you. So from the relations we have to calculate the maximum find. Suppose you have given if, so this if find maximum velocity, find maximum velocity, find maximum velocity. That means we have to calculate the value of maximum velocity from the given relations. Maximum velocity, find the maximum velocity. Now in this case you can see y is equal to, it is given y is equal to 50 sine 450. So normal equations already you know, y is equal to a sine omega t. So if we compare, we have to calculate the maximum velocity, that means B max is equal to A omega. So we need two variables. We need to calculate the value of amplitude and we need to calculate the value of angular frequency. Now y is equal to 50 sine 400 pi t and here y is equal to A sine omega t. So after comparing, so we are getting A is equal to 50 meter and here omega t and 400 pi t we can compare. So omega t is equal to 400 pi t, it will be like this. So t cancel, so omega is equal to 400 pi. So omega means twice pi. Omega, we have to calculate only omega, no need to calculate the frequency and all. So you just put the value of amplitude as well as angular frequency, then you can calculate the value of maximum velocity. So here A means 50 here, and angular frequency it is given 400 pi. So that means it will be 20 and here it will be pi. So this is the maximum velocity. That means we can write 10 to the power 4 pi meter per second. So this is the maximum velocity. So in this process or in this way we can easily calculate the value of maximum velocity. So this part is done, this part is done, this part is maximum velocity we have calculated, and normal velocity omega is, this is also we have calculated.